this would be a great place to do so. And that brings me to today's talk. Today's talk is called by Al Rodriguez, and it's called App Communication Juxtaposition. Al, as you can see, is a multi-classing wizard. I'm sure he'll explain what that is. I'm not familiar with that term myself. He's a .NET guy. I think he's also involved with the Orlando IoT group, if I'm not mistaken. And he works at SeaWorld. And he is big time into embedded development, and he seems to be big on the Xbox. So you can find him on Twitter at Programmer Al. And with that, I'm going to stop sharing, and I'm going to hand it over to Al Rodriguez. So Al, it's all yours.
All right, great. So I'm hoping my screen can be seen now. I don't know if anyone can verify that, but unless anyone pipes in and tells me, I'm just going to assume you can all see my screen. I'm getting a yellow border around the monitor, so I think that's what that means. So I guess before we really get started, all the slides and all the code that I'm going to be showing today, I have online on GitHub, and I already copy-pasted that link to today's meetup. So it's already down here. If you want to look at that later, feel free to just click on that link. And that's it for the little pre-amount of work, and now I'm going to go ahead and hit F5. We'll start running through some PowerPoint slides. It's okay. I'm not big on slides. This is just so that way I remember the order of the things I want to talk about. Also, I'm kind of playing around with the cool PowerPoint thing right there, where it'll take what you say and put it into text. So I'm hoping that actually works out. We'll see how that goes, but I just figured why not. Anyway, today we're kind of talking about essentially REST versus gRPC versus SignalR Core. I'm not a big fan on saying versus when it comes to technologies, but I just don't have a good way in mind to compare those two, or at least a better word, so I just went with that. Now, as far as the things that we are talking about today, essentially what I really want is to do a pro-con comparison of the different technologies as they exist. We're going to spend most of our time really talking about gRPC and SignalR. The only reason REST is in there is because it's common, right? It's the traditional thing. If you were to go out and make an entirely new application, it's kind of the default these days. And so I just want to have that there as the nice starting point. And the other big thing about this talk is to essentially, because we're comparing them, decide when would we want to use one over the other, right? So all three of those are great technologies, and they do have their uses where they excel versus the other two. And so we'll kind of talk about those two and kind of see how that all comes across. So kind of the reason that we're talking about this is because a couple months ago I was working on this side project of mine, and I was thinking, hey, I've heard about gRPC. That's kind of cool. It's we're getting a lot of that stuff just kind of built in for working with within .NET Core. And I've been hearing about SignalR for years, and I've never really worked with either one of them on a project. I've done some demos and read stuff, but I've never really gotten hands in on working with that technology or either of those technologies. And when you go online and you kind of start reading about them, you kind of get the feeling that they're very similar, but they're not, as you find out. There's a lot of stuff that makes them sound like they're the same thing, but they do have their pros and cons, when you want to use them, right? Everything in software is a series of trade-offs. So there's that. So that's kind of where we are. And then we'll kind of come to the point of deciding, when would you prefer to use one over the other. Also, we're talking about this because I thought it'd be a fun talk. You don't really see a lot of pro-con things online. I usually just see, everything just kind of, hey, here's the one technology. I'm a big fan of pro-con comparison things. So before we really start talking about each one specifically, if you only take one piece of information away from this talk, this slide is kind of the big summary of my interpretation of all this information. If I were today to go and create a new application, each of these is this slide essentially describes when I would choose each. If I'm choosing something that's going to be like a publicly facing API, there's going to be third-party people using it, or really just other applications that I don't control, some sort of REST-based JSON transport type of application, that's what I would go with. With gRPC, if I control other internal applications, so if I still need to send messages back and forth with other applications, but it's all something that I control, then gRPC is probably the best for that. And that's internal to your organization, your team, right? All of that stuff that you control. Now you can have that for publicly facing APIs. There's nothing wrong with that, but that's just one of those things where it's easier to do it that way. Also, gRPC of the three that we're talking about is the fastest from the perspective of the amount of data that it actually sends back and forth over the wire. It is the smallest when you serialize everything, and then I'm not 100% sure on the serialization deserialization performance, but at a minimum, it's probably on par with SignalR as far as that goes. And then finally, when we get to SignalR, SignalR is kind of best for when you're doing a pool type of application, or push application. So on your server, you just want to tell your clients, hey, this is the new data. This is the change. So that way your client doesn't have to constantly start polling. And then also, usually, it's when you control the server and the client too. It gets a little bit harder to kind of talk about those, or at least to communicate the fact that hey, maybe this message has changed. That kind of stuff. Documentation's a thing you have to care about there. Anyway, let's actually start talking about these. So, REST with JSON, right? Like I said, if you were to go out and create a new API kind of thing right now, this is probably what you would start with, right? Or at least this is what most people would start with. I would start with that. And that's why I put traditional in quotes, because it's kind of the default. The other benefits are that it's very loosely coupled. So if you are into the one if you are the one controlling the server, but you're not controlling the things using it, other third-party clients, it's very easy to just go ahead and get started. It's very loosely coupled from that perspective. And then lastly, as far as JSON goes, with sending that back and forth, it's human readable. So when, not if, something goes wrong, you can at least look at the message, right? What's the data going back and forth? You don't have to worry about having to serialize or deserialize whatever is going over the wire, because you're able to read it, which is nice. So with that, let's look at a quick demo of some code and just kind of overview of the stuff that we're going to be talking about. So this Visual Studio solution right over here, I have essentially three different projects. So we have the REST-based service and a client, and then we'll kind of talk about this display thing later. That's just for extra bits of info that I kind of want to touch on when talking about these. So when I went and created this application, I just went into Visual Studio and did the very standard ASP.NET Core application with an API. So if I start expanding this, the first thing you would notice is that if I look at the startup.cs file, this is all just the basic stuff. The only things I changed in here was to get rid of the little warnings saying that I'm not using the returns. That's why I have the discards. But that's it. Everything else in here is the complete default stuff. Now with that, we're also going to look at an entity class, and this is the person entity that we're sending back and forth. So notice that for this class, we have some ints, some strings, right? So some native values. We have a couple of arrays. One array, this email type, is an enum. And then this settings array over here is just another object. So I just wanted something nice and simple, but can still show the difference of different types of things that you would be sending back and forth across your applications and how you would be using those. So finally, we'll go to the actual controller, and we just have two endpoints right here: a standard, hello person, right? So it's just returning that text, and another one, which is essentially a lookup, right? We're going to be receiving some sort of ID value, and for our demo, we're always just going to be returning a new instance of the same data. But if you were, if you had your own application, it would hit a database or something else, right? So that's the general idea. That's the very basic application. Now, let's move over here to the client, and on the client is just a .NET Core console application. And as far as getting this data, this is pretty simple. We're going to create a new instance of the HTTP client, and then we're just going to send a message onto the endpoint, right? So we're going to say, we're going to hit the hello endpoint, and we're going to read the context, we're going to read the content back out and output the text there. And then the same thing with querying a person. The only difference there is that we're going to have to deserialize on our side, right? So I'm going to go ahead and hit F5, and we'll actually see the output, and it's exactly what you're going to expect. As soon as it starts up, it should be exactly what you expect. So we'll minimize that, open up the console, and then I'll let's see, zoom in right here also. So the JSON there, not very pretty formatted. Oh, whoops, that's the wrong console. This is the console application. Sorry about that. That's the other one. So this is the data that you would expect. Hello Homer and 5 Homer Simpson, right? That's the data we were saying right here. The 5 is the ID, the first name, last name, etc. So that's exactly what you would expect, right? So if you were today going to be interfacing with any other endpoint that you want to talk to, this is the type of code that you would be writing in C#. Probably not exactly as a console application, or maybe it is. I don't know. Now let's talk about the other display project that I had talked about. So this is the one where I was accidentally showing you that console. So the stuff in this project is just kind of to show you just a few other things that I want to talk about for using these types of technologies. And we're going to have something like this for the other two, for GRPC and SignalR. So the first thing we do, we're generating a new instance of that person, and this is exactly the same data. You're going to see this method throughout all of the projects, so I'm just going to stop talking about it. It's the same data. So the first thing that we're going to do, we actually want to compare serializing and deserializing the JSON using the two different I want to say popular serializers. So the first one is probably the one that we're all using every day. Day in and day out with whatever .NET project we're working on. It's the Newtonsoft JSON one. The second one is the newly built into .NET Core one, which I want to say came out with .NET Core 3. I don't remember. Don't quote me on that. Let's just pretend it's correct. So this is built into .NET Core for serializing, and so you don't have to reference Newtonsoft.json. Now there are reasons why you may have to or want to stick with the Newtonsoft JSON one, and the reasons for that is usually feature set. From what I've read but haven't really looked into, is that one of the reasons for performance is that the newer system text JSON one doesn't have as many features. Anyway, I'm not an expert on this. We're going to move on because I don't want to keep talking myself into a corner. So we're going to output what that serialized JSON looks like, and you kind of have already seen it. The next thing that I want to show is that data the same when we serialize the Newtonsoft JSON 1 and the one built into .NET Core? I already kind of have the data out there in comments. False. They're not actually the same. And it's the same amount of characters. I'm assuming it's like a spacing issue. That's kind of what that comes down to. The next thing is the length, right? It's going to be the same amount of characters. So there's probably some white space character or something off in a corner that's different. I'm not sure. Anyway, but the important thing to remember is that because when serialized, these are 323 characters, that's how much data you're sending over the wire. So from your server out back to the client, or however many clients are calling this. Now, that's uncompressed, and one of the things that we can do in order to save on some of that cost is to also compress those messages. So if you're using IIS or whatever other server technology that you're using, you do have the ability to send that data compressed. And so how that works is usually Gzip compression. So I added some code in here to do some Gzip compression, just what that looks like, and you don't have to do that in your code, but as an example, when we compress it, we're sending 244 bytes. So that's a difference of some number, somewhere in the 80 range. I should have done that math in my head ahead of time, but I'm already talking, so we're going with that. And then I guess I'll hit F5 and show everyone this again. There you go. So that's what the data looks like serialized, right? That's JSON. You're probably already used to that. You know, it's the whole key value pair thing. ID right here being the key, and you've got the value 5, etc. You know, strings always have double quotes around them. This integer over here doesn't. All of that stuff. Again, JSON.net and system.txt. JSON has 323 characters, and we're down to 244. All right, so that's it for the JSON stuff. I only wanted to bring it up really to set a baseline and have something nice to compare these others out to. I meant to ask ahead of time if we were going to be doing questions. I have no idea if I should just keep talking, because now is kind of a decent stopping point if we have questions.
Al, if there are questions, I will chime in. Currently, I'm monitoring the chat and there are no questions.
Okay, perfect. Yeah, that is easier for me. Cool. So let's get back into this. I think that's the button to press to get back into it. All right, perfect. So back into the slides. The next thing that I do want to talk about is GRPC. So what exactly is GRPC? What does it stand for? Because it's obviously an acronym for something. And if you look online, you get two answers. One is it stands for Google RPC. The other answer is that it doesn't stand for anything because Google didn't want to give it an actual name. Either one works. I really don't care. But GRPC is it's another way of sending data back and forth. So GRPC is built on top of another technology Google developed called protocol buffers. You may have heard of it as called Protobuf, and I may go back and forth, but I think the official name is protocol buffers. Essentially, protocol buffers is a binary encoding scheme. It's based on a schema. You have this other file called a proto file, and that's where you type out the whole schema for all of the messages that you're going to be sending. So if you were to compare gRPC and protocol buffers to what we were just talking about, you know, REST with JSON messaging, gRPC would be REST, and protocol buffers would be JSON in that type of analogy. Some people have probably called it a spiritual successor to WCF. I don't know if anyone has, but I assume that people have said that.
Al,
yeah.
I have a question myself.
Yeah.
So I remember that we used to do RPC over WCF, and so I'm trying to figure out like how that fits into the whole gRPC.
Yeah, so it's been a while since I've really looked into WCF, and so I'm kind of trying to remember what you mean by that. But by the
it was basically you call we've done RPC at different levels, right? WCF was just one of those. The ancient .NET also used to have RPC, where you actually did remote procedure calls from machine to machine type communication. But the WCF thing basically enabled it over the internet, if I'm not mistaken, or at least made it better over the internet. But you basically called methods and passed messages to endpoints. So that's kind of my remembrance. So I'm trying to wonder if this is similar to that or successor. Obviously it's much better because people like it, but I'm just trying to fit it into the view frame of developers who may have worked in that ancient paradigm.
Yeah, so I mean, essentially what you're doing with gRPC is kind of the similar concepts. With WCF, you were probably working with a WSDL schema file, right? And you were generating your endpoints that you were able to call. And so with gRPC, you're pretty much doing the same steps. Different syntax, different kinds of files. It's not XML based, but you're still doing the same thing as far as generating a lot of files that are used by the client, generating files used by the server for the actual service itself for hosting these endpoints. And so a lot of it is from that perspective. And everything goes over HTTP2, as we see on the slide right there. So you get all of the benefits that you get from HTTP2. I have no idea what they are. I'm told performance is one of them, and that's one of the reasons why Google wanted to specifically force it to be HTTP2. And so if you have any real interest in looking into it, we have those links right there. But before we stop talking about this, we have a demo. Yay, demo. I'm a big fan of code demos. So let's move over to this other instance of Visual Studio that I have open. And I just want to say that this is exactly the same setup and types of things that we're going to be calling, like just talking about on the REST-based side. So the way that I generated this was within Visual Studio. I just typed in GRPC and waited for it to search, and I let my machine stop freezing up. Okay, yeah, that's what. So then I click next, and then if you hit create, it'll go ahead and generate an ASP.NET Core web application that's hosting gRPC. Now I'm not going to do that because I already have one created over here, and we'll start looking at this. Now remember when I said that gRPC is built on top of protocol buffers, and that's essentially the kind of the glue of these messages. So over here I have this person.proto file, and so this is the file that's our schema. This is going to generate all of our entities, and on the server and the client we'll generate different files that we use for either hosting the service itself or for being able to connect to it as a client. So over here on the left, notice, like I said, this is different syntax. So if we're comparing this to WCF, this is how we're defining our endpoints, and then all of the messages that we're going to send back and forth. So let me scroll down a little bit, and we'll talk about this person message that we're creating. So int32 instead of int, right, because it has its own syntax. We have a couple things that are strings, and then for anything that's a collection, an array, we just have to say that it's repeated. There are a few other keywords within protocol buffers, and they're all nicely documented online. But for simplicity, we're just going with this. The other thing that I want to call out is the number right here. I forget what the name of that means, but that is required by the protocol buffer syntax. What this is essentially saying is this is the field in the message. So because this is binary encoding, this is different than JSON. Like I said, JSON has the key value binding. So oh, well, this is for this key of ID, this is the value of it when parsing is whatever the value is before that comma. But when it's binary, it's a bunch of ones and zeros at that point. It doesn't have that extra layer of text as the thing that you're actually parsing. And so, however, protocol buffers, serializes that and deserializes that, it needs to have this number to know which order the field, because it's always going to read it in this same order. It'll deserialize or serialize it into this order and then deserialize it in that order. So that's the part that matters for those.
Does the ordering matter for the numbers? Like, can I say family member ID equal to 7 and preferences equal to 6 in that?
No, yeah, the order doesn't matter at all. Yeah, so basically if you're saying, hey, can we start doing this, move this around, that's fine. If you want to skip numbers also and just say 9, I'm not actually sure. We could test that, but I'm not going to do that right now. But as long as you do have those numbers, you're good. One of the things to remember, though, when working with protocol buffers is that if you're using this for APIs, internal or external even, right, you still have to support other things connecting to it from that perspective. And so all of a sudden, if you say, well, we're not using setting anymore, and it's going to be some other object called setting2, you do have to worry about that. Like, this is a thing that you have to do. So a lot of times the recommendation from Google is if you're going to be replacing something, you have to essentially support it and then make a setting2 and then field number 8. Yeah.
Question on the chat. Mm-hmm. Dave W2040 asks, are there problems with arrays of items if it's a fixed size set?
Let's see. I guess I'm not too sure what you mean. There are problems with areas of items if you have a
No, no,
fixed.
arrays, arrays, as in arrays and sequences.
Oh, okay.
Yeah.
If it's a fixed size, so I'm not too sure. I mean, I haven't experimented with that side of things. So when you have any kind of collection within gRPC, it actually uses its own collection type. So, and that's actually things we're going to see in a minute. You're not when you're creating an instance of this person class that we generate, you're not setting the allowed email types to a new array. You're actually setting it to an instance of its own generated like repeated collection. So if you have an array of size 10 and you're only adding 5, then basically you're fine on that. You kind of just add and remove from it like a list is how it's treated. So I hope that answered the question.
Yeah, I mean, that's a great explanation. And if I have follow-up questions, he says, I think so. Thanks. So,
yeah. All right, cool.
So
yeah. All right, we'll see some code looking at that in a minute, and that is exactly one of the things that I wanted to call out. So before we get into other C# code to talk about, I do want to look at a few other things. So these are all the messages, and then as far as a service, the endpoints, that's what this service section is right here. So just like with our RESTful-based endpoints, we have two. We're going to have that say hello, where we will receive this hello request, which is just the name. So we'll say hello Homer, and the reply is the exact same thing, right? So it returns an instance of the reply of just whatever string message. Same thing with that get person. So we'll receive an instance of this find person request, which is integer, and then we will return an instance of person. So exact same concept, and a lot of this stuff is generated. And for that, let's go and talk about the startup. So when we were talking about the JSON REST-based side of things, I said that this startup CS file had just all of the defaults. That's basically true on the gRPC side, but the only reason I'm saying that's true is because when I generated the project, it was already added for me. But similar concept, in the configure services, you do have to call the method that says, hey, ASP.NET Core, load up whatever DLLs and bits you need in order to work with gRPC. And scrolling down, you also do have to add the line that says, hey, manually map up our service that we want. On the REST-based side, .NET Core will do that for you, but we just have to remember to add that. So if you have 3 services, you're going to have 3 lines right here that you have to add, and that's it. So let's actually look at the service. Okay, so this is the service. So very similar to that REST-based one that we were talking about. We just have 2 methods, and then that generates standard person. Let's look at that because we were kind of talking about it already. If I'm going to go ahead and create a new instance of person right here, we have the same data like we were doing with the JSON, but those repeated fields are not instances of arrays. They're essentially like a list. They're a repeated field, and so we do have to add them, like properties one at a time. So that's kind of how you work with that. You can add range or add an individual. You can remove from them. They're basically a list. It's just something that something else that has been created, and I'm sure it has to do with however they do serialization, deserialization. It's probably for those reasons. And so for reasons like this, I personally don't want to start sending these repeated field types all around my application because it's not the native thing. So I would probably have the entity that exists for what's being passed back and forth, and then separately in your application then just create another entity of what you would actually be using internally, which is also something that's recommended, right? You only have the entities for what you're sending back, and have that different from what the rest of the application uses, because you don't want that bleed over of properties that are needed internally but are never actually sent to the client. Then you have to deal with that, and that's its own mess. So just something to keep in mind there. All right, so let me so now we'll scroll up and we'll look at these endpoints. So to say hello, very, very simple thing. Like I said, we receive an instance of that hello request, is what we saw over here in our proto, and we return an instance of that reply. And same thing over here with getPerson, right? We receive an instance of that request, and we return an instance of the person. We're doing everything in an async type of fashion, so that's why it's all wrapped in tasks. And you're probably noticing, hey, this peopler base, and also we're overwriting some methods. So that's a little weird. Why is that all overwritten? Well, the reason for that is because this person proto file over here is automatically it is taken by ASP.NET Core, and it generates a bunch of files for us. And so if I go back and look at this base class and hit F12 and we look at it, this definitely looks like a file that's automatically generated. It's not the sort of stuff that we would normally write. Yeah. So peopler base exists right here. Notice that those endpoints say hello and getPerson, those exist. It's virtual. If someone tries to call it, we'll get an exception. Same thing if we go to the definition of person, right? I didn't write any of that code. It has all of that stuff for us. And so this is all generated at some point. I assume the underlying tooling will figure out when it does that, probably whenever that proto file changes. But it has a bunch of stuff in here, and I just try to avoid looking at it. But it's all there for us. And the way that works is by referencing some things within the actual project itself. So here's the CS_proj file, and only two things within this actually matter for gRPC. First is the reference. So we want to say that we have the ASP.NET Core bits for gRPC. And the other one is that we need to say in our project what proto files we actually want to include. So I'm making sure to include only the one proto file. So I guess if we have 20, and we only want one, we'll only have the one. I didn't think about that until now. But this is us saying this is the file we want. And also this other property needs to be set to say how we want to generate it. So what we're saying by server there, it's essentially there's only two flags. You have server and client. On server, we're saying when we generate a bunch of stuff, we want the stuff from the perspective of a server. So we want to generate the service. We want to generate this peopler-based service class because we are hosting an actual application. And that's where everything comes from. So lots of stuff is hidden under the hood for us because we only have to add those two references right there within our .NET Core ASP.NET Web application. And that's the server. So like I said, this is exactly the same as the REST-based JSON example, only it's done in gRPC. So let's look at the client over here. And notice that with the client, we have the same, I just copy-pasted that proto folder that exists down here. And then we have a program.cs file. So opening that client is exactly the same type of stuff that you would be doing on that REST side. We're just using different classes. So over here with the channel and client, we're just saying, hey, we need the address. So the channel is the thing that you're actually, your endpoint essentially. And then this client is generated from that proto. So remember how I said, hey, I just copy pasted that person proto. Well, if I open up the CS_proj for this client, we did have to add a few other things as far as our references to what we need in order to work with Protobuf. But our person proto, when we included that, is a client. So because we said it's a client, we get the stuff as a client. So that's why we get the peopler client class right here. That was not generated on the server side. And so because we have that client, now all of this stuff is generated for us. We're able to just call these methods. So we're remote procedure calling say hello async. And then the same thing with getPerson, right? So we're getting our instance there. So we can call this stuff, and we're just going to output the same data, the exact same data that we outputted when we were calling the RESTful-based methods. And so I just hit F5 to debug, and some things are popping up. And all right, so over here on the right, we're going to see the actual service, and on the left, we're going to see the clients. So notice that it called it, and then over here on the right, so we got our nice debugging information saying that we called it. So over HTTP2, because like I said, everything in gRPC is called over HTTP2. We called say hello. It ran for apparently 131 milliseconds, and then right after it, we called our getPerson, and that ran for even less time, probably because it already JITted some stuff. So that's how simple it is to actually interact with a gRPC client. like I said, conceptually, this is exactly the same as working with the RESTful-based side, right? You're still doing the same kinds of steps, differently, different syntax. But my big thing, the reason I love it so much, is that we have a schema. I was one of the people who went kicking and screaming, leaving WCF or other SOAP-based services, because I like having strongly typed code. I want the tool to generate stuff for me, and all of that stuff. All right, looks like we have a question.
Yeah, question again from Dave. Out of curiosity, are channels or clients expected to be short-lived objects or exist for the lifetime of the app?
That's a good question. So I don't know, and just kind of looking at this really quickly, hitting F12, I'm looking for something very specific to see if I can figure this out, and I don't know. So I'm wondering, if, I'm assuming the reason you're asking is because I know with HTTP client, we don't want to just go and create a bunch of instances of that, because with that creates something on the operating system side where now you're taking up all the threads. And so with that, you usually want that to be long-lived. I don't know the truth on the client here, but probably I would believe that it has the same kind of limitation. So I don't know the exact answer to that. That's a great research question. And if you find out, you can tell me on Twitter, because now I'm curious. But if I were designing an application, I would probably do something similar as far as keeping it longer lived than a new one for every instance, right? You know, right here, yep. I used it twice.
Yep, he said there are some gotchas with the HTTP clients, so I think that's where he's coming from.
Okay, yeah, same concept. All right. Cool. So that's the server client. So let's talk about this display class, because I just wanted to talk about a few other miscellaneous things, and this is really just around the size of the data. So when serializing, I just wanted to show and compare this to compressed JSON of what this looks like. So when serializing this person object right here that we've been talking about, we end up with only 161 bytes. Oops, I thought I turned that off, all of those pop-ups. Alrighty, so as you can see on my screen right here, the output of the binary, which I'm sure you don't get any value out of, I sure don't get any value out of, but I just wanted to point out that it's not human readable, unlike JSON, but it's way less data that you're sending over the wire, and we didn't have to compress it because it's already compressed. So 161 bytes compared to, and I have to pull that up to find out again, the 244 bytes compressed of JSON, or by default, I already forgot the number, 161 default versus uncompressed 323. So that's half of default on that. So when we're talking about performance of these these choices of technology, this is something that you get for free as far as on the protocol buffers and GRPC side. Looks like we have a question.
This is a question from me. Can you compress it further?
I don't know. I haven't tried. My assumption is that you can probably try and see what happens. I mean, when you receive it, you'll have to decompress it and then deserialize it. I believe so. The way that it works when serializing, and that's actually why we have to have the numbers right here at the end of a field. That has to do with the bits. Basically, every byte that is generated or serialized out to, the first bit is a flag determining if this is the, I forget if it's the first or the last part of the field. So what's going to happen is even though this is int 32, if it's a maximum integer, if you're using all of the possible bytes that you can, it's going to be 33 in total, because it only actually uses 7 bits per byte of the actual value. And so the reason that I'm going on that tangent is because I guess it's possible to mess up the bytes, but I guess you can, and I didn't even think about that at all. So, but again, if performance matters that much, where you're compressing something like this, then that's definitely something you're going to want to go and benchmark yourself, right? So you probably want to pull out something like benchmark.net and just see, what do you get from a serialization, deserialization, amount of time. Like, see if you actually gain anything from that. And then also compare the actual lengths that you get, right? Like I said, right here, 161, but you're going to want to try it with a bunch of different pieces of data, right? This is a string with a 5-character name. See, do you actually gain anything when you have a 20-character name and things like that? So, maybe. I would assume that you can, but you're probably only saving 1 or 2 bytes. It's probably pretty low.
Okay, thank you. It was just a strictly academic question. Yeah.
All right, cool. All right. I'm assuming there's no other questions because I don't see anything else. Nope, I'm seeing shaking of the head. All right, so let's get back to this, and we'll talk about our last topic of SignalR Core. So the big thing with SignalR Core is that generally you're pushing that data out. So from a performance perspective, one of the things that you can get is having to send less data over the wire, right? So if you have a client that has to poll every second or every 10 seconds, right? Instead, just let SignalR Core keep track of the connection for you, and then when something changes, send that back out to the client. So it does this over WebSockets, and it'll, like I said, it'll track everything for you. And one of the other nice benefits about SignalR Core is that it supports 2 different ways of sending that data, either JSON, which is the default, or message pack. And message pack is another binary serialized format. So same concept as gRPC in terms of how it serializes and deserializes that. So if you care about performance, definitely go that route. But the other benefit of having JSON as an option is that when, not if, something goes wrong, you can look at that data and figure out what's going on. I mean, most of the time you're not going to care, but if you really want to see that value and you just want to be absolutely certain, then that's something that you can get. And that's it as far as these slides. Oh, and if you want to learn more about message pack, there is a link right there. But let's actually look at the demo and the code and everything. So like I said, same type of application. So here's the thing about SignalR. When you have to actually think about how you design the application, it's going to look different. On the REST-based side and gRPC, you had the exact same concept, right? You have a client that calls an endpoint, which is however you name that endpoint, and then it returns an instance of whatever data that you want. On the SignalR side, you can do that. That's actually something we will see an example of that. But also you have that push perspective. And so that's where things are just different as far as how you architect it and how you kind of work with that stuff. And that is why this is the only of the demos where we have a different shared project. And I could have done it for all the other ones. I just didn't do it because traditionally you probably won't. You'll probably have your code base for your client in a separate code base from your server. So, and that's actually another reason why I had mentioned that earlier in one of those early slides where usually you're using SignalR Core when you are controlling the client and the server. All right, so it looks like we have a question.
Yeah, again, from me. So you mentioned that it uses WebSockets, but that's not always a guaranteed, right? Sometimes it has to fall back onto other protocols like server-side events and long polling and stuff like that.
Yeah, exactly. Yeah, so I probably should have put more effort into the slides. I'm more of a jump into the code as an example kind of guy. But no, you are exactly right. By default, it tries to use WebSockets where possible. But if for some reason it can't, and I think if you want to, you can disable that. But it will try to go over other transports. So long live or polling essentially, where you lose the benefit of the WebSockets at that point, but you still have the benefit of your code doesn't have to, you don't have to manually add that code to keep checking. So that's something to keep in mind, and that's completely dependent on what the browser supports. So older browsers like IE and other ones that we like to make fun of don't fully support that. So so that's definitely something that you do want to keep in mind when working with these. But that is also a browser-only thing, and actually, I guess that's one of the things I haven't really mentioned. All three of these, as far as what we're talking about, is cross-platform. On the REST-based side, all you need, as long as you can make an HTTP call with whatever tooling you're using, you can work with that. So it doesn't have to be just a browser. And the same thing is true. With gRPC asterisk. There is some tooling for generating that, I think, for browser, but as far I'm not 100% sure. Don't quote me because I haven't really looked into it. I know there is some experiments, but I don't know how many things are actually fully supported. But I do know that as far as if you're working with whatever choice of programming language you want, there's something that you can use. So if you're going to do this in some sort of application, mobile app, desktop, etc., you have that tooling. So all of these are cross-platform in some way, and the application, when I mentioned at the beginning, hey, these are the reason for this talk is because I had the exact same question of, well, what should I use for my specific scenario? I ended up going with SignalR, but it's not using a browser at all for its interaction. It is still client server, but the thing running in the client is a .NET Core application. All right, so let's actually talk about the code here. And so I'll expand the service. And so first, I want to go ahead and start in the startup CS file, and just to compare the differences. So just like I said with the on the gRPC side and on the REST side, all we have to do is add a little bit of stuff at the beginning to say, hey, load up whatever bits you need in order to work with this. So we had to do the same thing with SignalR, and then also separately we also had to tell it to whenever you're doing anything over SignalR, use message pack. It's not on by default. I really wish it was something that would be done by default, but I had to look up the NuGet reference. This is the NuGet package that you need to reference in order to get the extra extension method that tells it to load up message pack and all of that stuff. So that's something you do have to do manually. It is a hassle. I'll talk about what this means in a minute later, but separately you also have to, just like with gRPC, just like with REST-based methods, you just have to tell ASP.NET Core, hey, just map this other thing, this is our service, all of that stuff. So same thing you're doing with all those other conceptually. I just want to keep hammering that conceptually a lot of these are very similar. It's just slightly different how you actually make it. The other thing I actually kind of skipped over is how did I generate this service? When I showed you, the ASP.NET Core REST-based stuff and then gRPC, we had some nice templates built into Visual Studio for us. Unfortunately, we don't have that with any kind of SignalR service. I had to go online, look at the documentation, and start copy-pasting code. Thankfully, everything on the Microsoft Docs for this stuff is really nicely organized, but it's a hassle, right? It's not something that automatically generates things for you. So just something to keep in mind. All right, up next, let's talk about the hub. So, on the other two things that we talked about, those were services. On SignalR, they'd like to call it a hub. That's it. It's the only real difference on that side. Just I like to still think of it like the whatever endpoint, it's a service. It still has a full URL as far as sending and receiving messages. So same concept. However, this one does actually look kind of different. So notice that for a hub, we're inheriting from two different things, and we don't have to inherit from as much. This will work. But you don't get as much fun, cool, generated stuff for you. So I like to use interfaces wherever possible because I like strongly typed stuff everywhere that I can. So as you can tell, I'm not a big fan of scripting languages. I think they're great. I just avoid them because I would rather have a tool tell me I did something wrong. All right, anyway. tangent aside, let's actually talk about it. So we do have those two same endpoints like before. We can call from our client the say hello method. We're just going to respond with some text, or we're actually doing something slightly different here with that person data. In the other two examples, from our client, we were doing a pull-based method. We were sending a message up to the server, trying to get this data, and the assumption is that the client was probably just waiting for something to change. Maybe some settings could have been changed or something to that effect. Instead, we're going to do it push-based. So from the server was going to receive an event in some way, and then it's just going to tell all of the clients, hey, this person has changed. It's a demo, so we're not doing anything too crazy there, but you can imagine that something from your own application, if you're working with multiple services, maybe you have this application as your front end application, and you have a couple of services internally, and you gain some event like, hey, this person they updated some setting, and so you're going to send that through however you want to send that, maybe as a gRPC call from one service to this front end one, and then that'll receive the event, and then it'll go and tell all of your clients. So that's why we're architecting this one slightly different, because that's what SignalR is for. That's the whole reason. Now within this alert person is updated, both of these will work. Like I said, I would rather have the syntax there. I would rather have the compiler generated stuff there. So instead of using a string everywhere, I'm using the interfaces. So the reason that we have this interface is to know that on our clients.all we have access to all of the methods that are on the client. So this method is because we have a hub saying these are our clients, and if I go to that definition, that's the only method that it has. Right, so we're saying all of our clients have to have a method with this name, and they're going to receive an instance of person. That's what we're saying there. So we are a hub for that client. We are also adding an interface here for the server, and that's because I want to do the same thing on the client. I want the client to have strongly typed references to know about this say hello method. Now we don't have to. We can always just use a string, and I'll show you an example when we look at the client. But having references to those interfaces gives us that strongly typed set of things. So that's a completely preference that I have, but you can go either way. And with that, let's actually look at the client. So we're going to come back to this server in a little bit to talk about some other differences that I've made, but I just want to show you the client connecting that. So setting up the connection is going to be different, right? We're not just using an HTTP client, and it's not like gRPC where we have everything generated for us. So a lot of stuff is similar. We're going to go ahead and create our connection. So that's what these first two lines are right here. On our client, we have to say again, use message pack. So it's not on by default. We have to, and also for our sockets. We have a nice extension method there to automatically reconnect. So if something happens, if something breaks, I want to make sure that our client will just keep trying to reconnect as long as it has to. Currently, if you were to go and create a new SignalR application, by default it does automatically try to reconnect, but it wasn't always true, and I would rather be on the safe side instead of update one day and find out that broke, because that's never the thing you want to find out after spending an hour updating things. So then we start our actual connection, and we are going to have some events just to know, hey, if the connection closed or reconnected, and we'll see an example of that later. But all we're doing there is writing out to the console just to see the text, so nothing crazy. We'll talk about this one in a minute, but first let's actually talk about the say hello function. So either one of these will work. I can either use this hello result, and we'll do that. So this hello result will actually call that say hello method, and we're just going to give it an argument right here. So this is the less type safe way, but here we're saying we're going to call say hello on our server. Here's the one input. However, I like to instead use as much of the compiler to help me wherever possible. So instead of sending just a string, I'm going to use name of and then the say hello. So looking at the server, so this is one of the reasons why I had my server inherit from this interface, and then also why I even have the interface, so that way I can have other parts of my code add some strongly typed stuff. So if I ever change the name of this method, then this will also change because now we've got some strongly typed stuff there. I still have the same concept there, sending arg1 string, etc. And so we'll put the output there. So that is if you want to do the exact same concept of from your client calling something on the server with SignalR, completely supported. But again, that's not exactly where it shines, right? That's not the big thing. You'll probably do that if everything else is SignalR, and maybe that's less of a thing that you want to do, or something that you want to do less often. But then again, if your entire application is SignalR, then I guess you'll end up with that. But again, this is something where it's great when you control the server and the client, but otherwise now you're just having magic strings all over the place, and that's less fun. So now let's talk about the prize, the bread and butter of SignalR, of actually receiving data over time, right? We want something that's going to be called over and over. So let's demonstrate that. So from a client perspective, this looks like weird syntax, and I kind of forget it every time. So I do have to look at an example every time to kind of copy paste some stuff. But what we're essentially saying right here is, all right, for our connection to our server, when we are being told that this method is being called on our client, the receive updated person, we want to call this actual method down here, the receive updated person method. So one more time, just reading that out loud. For the connection, for the server we're connected to, when it tells us to call this method, we're just doing some plumbing, and we're going to call this thing right here, receive updated person. And then we have a generic here to know what data it actually receives. And that's it. Then it's just going to output to the console. All right. So the last thing is, let's actually set up our service to send that data repeatedly. So like I said, with something like SignalR, you're going to be reacting and saying, hey, this event happened, let me tell all of our clients. So you have a bunch of different ways of doing that. I gave the example earlier of receiving something internally, like from GRPC, Json, whatever you want, however you want to receive that event, and then you use your instance of your people hub, and then you just call this alert listeners person is updated, right? That's one way to do that. Because this is a quick demo, and I didn't want to go and set up another project and do all this stuff, I'm doing it a little cheaty way of created this class called person updater. And so what this is going to do is create a task that's just going to run forever. If we look at this, we're in a while true. We're going to wait for a second, and then just on all of our clients, we're going to call receive updated person. That's it. So that's why you may have noticed earlier when I was in my startup CS file, I actually added a singleton for this, so that way to say it exists and say, hey, container, just know about this thing. And then down here at the bottom, I said to actually generate an instance of it. We're not doing anything with it. That's why I have the discard. But as long as the instance exists, then this task is going to keep running forever. That's why we have the while true. So that's what it's there for. And the other thing that I wanted to show off is other things using this instance. So you can kind of pretend that this is similar to the other scenario where I was mentioning of you receive an event from something internal, like the GRPC call, and you say, okay, cool, well, we received an instance. Well, I want to, within the whatever controller receives that instance, I want an instance of this hub context. So this is our people hub, that thing that we were just talking about, and also an instance of the client. So that's why within this while true, I'm able to call the receive updated person. If I don't have the client right there, that's fine. That's an option. This will still compile, and I can get that. However, this part down here won't compile. You already see the squiggly line. So then I would have to do the thing that I'm doing over here of copy pasting, and then this would work, but I don't like that. I would much rather have the compiler do everything there for me. So that's why we're adding these clients all around. The downside is now that we have all these interfaces, now you're just kind of sprinkling these things all over. So that is a downside, but it's a lot nicer to do it this way. So with that, so now that we know that we're actually going to be just generating an instance and sending it to all the clients every 1 second, let's actually look at that running right here. And so we'll wait. All right, perfect. So let's minimize that and that. And so here's our client. So I'll hit enter. And so the first thing is that say hello. So the client did call the server and got a response. And now every second we're getting this data right here. And oh, whoops, I did something wrong. Sorry. I want to hit Control F5 because I don't want to be debugging. So let me close that one. And we'll hit enter. And so what I want to show here is the automatically reconnecting ability. So now that that's running, I'm going to go ahead and stop the instance of IIS that I have right here. And notice on the console, hey, we're no longer getting any data because the server's down. So I'm going to go back over here and set this as the one startup project, so our service. And so I'll hit Control F5 one more time to start that up. And then go back to the client and notice that it reconnected. So this string right here, it's a I forget what the exact name of it is, but it's essentially your connection string, your client ID, essentially. So yeah, so we're continually getting that data, and that is essentially SignalR right there. And so the last thing that I do want to mention, kind of talk about, is that display class, or project, like we have with everything else. Sorry, let me close that. And so I just kind of want to show you, just to compare this versus GRPC in terms of serializing, deserializing. Because we don't have things automatically generated for us, we do have to create a serializer. So I had to use add a NuGet package for this to get this message pack serializer. So I get an instance of it. I do a little bit of code right here to serialize that object out to an array. And then we output the array itself, all those bytes, and how many there are. So I guess I'll hit Control F5, and I guess I didn't hit Start as set a starter project. So there you go. Now you see a whole bunch of bytes for some reason that I thought would be nice to put on the screen. But also you see the fact that this is 172 characters. So again, that's compressed by default. That's 172. Versus GRPC had 161, so that's a nice 11 character difference, or 11 bytes difference. And then again, comparing that to, compressed and uncompressed JSON. So lots of different stuff there, at least on the performance side of in terms of how much data you're sending back and forth. As far as serializing and deserializing, again, that's something you're always going to want to check for performance on your own applications. I do know that GRPC and SignalR with message pack are faster than JSON in terms of the CPU time for serializing, deserializing. But which one is faster? Probably completely depends on the messages themselves. So just kind of wrapping up in the last few closing thoughts. There are other ways of communicating with our applications. GraphQL is a really cool technology that I have not had an excuse to actually go and learn it, because that's how I learn things. I need an actual project. I'm not just gonna follow some tutorials, because I just forget everything after that. But if you haven't heard of GraphQL, it's really cool. My understanding is that it's essentially another layer that you add on top of your REST-based API, and it lets your client choose what data it actually wants to get back. So as an example, we kept using that person property, but we were only actually outputting 3 properties, right? The ID and the first name and the last name, but we were still getting everything back. With GraphQL, you can say, I only want those 3, and then you're only sent back those 3. So that's my understanding of it. I really hope that's correct. Another way to interact between your applications is with message queues. So there are a handful of different message queue protocols and server technologies out there. RabbitMQ, lots of other ones. That's just the only one I can think of for some reason. But the benefit there is you send your message onto a queue, and then something else can interact based off of just constantly reading from that queue. So now you have a nice way of separating your services, and tying that back to something that we talked about, like on the SignalR core side. You can have your ASP.NET application continually reading from a queue, and then when it gets a specific message, then it tells all of your clients about that message. So that can also be another way that you're using these other ways of communicating. Last thing, I kind of added this slide last minute. I was scrolling around the internet the other day, like I do, and found this actually really well thought out article written by Google on gRPC and when to use that versus REST and a couple of other things around it. I did not finish it because it was actually very in depth, but it's just wanted to make sure I shared that with everyone because it was really nicely written, and I told myself that I will go back and read it. I mean, it's in my pocket list, as are like 50 other articles, so we'll see what ends up happening. And finally, the last slide, Shameless Self-Promotion. You can find me online. That's my handle, @ProgramMorale. I try to take that everywhere, there, GitHub, etc. Also, I'm one of the 3 directors on the Orlando IoT meetup, so if you're interested in that, we are having a virtual meetup tomorrow, which will also be streamed online, and I should have saved the link or something, but you can just find it if you go to meetup.com, just search Orlando IoT and you'll find that. So tomorrow night at 6:30 or 6 if I remember. Wow, I'm a bad director. Anyway, that's the end of my talk. We'll stop before I reveal other things I don't actually know. And I don't know where to go from here, I realized.
Excellent. I am looking for questions. I don't see any questions, so I do have one question in terms of use cases. So you talked about REST, you talked about GRPC and SignalR. So it seems like SignalR is useful in a more push type scenario, where you'd want to like push out updates to multiple machines, or you want mobile notifications and stuff like that. So, and GRPC, it seems like the whole purpose of RPC is machine-to-machine communication, which is fine. I mean, by overriding that, you can say that I can use it as a web service, but it seems like it's kind of trying to replace web services. Is that, am I guessing that incorrectly, or is that just my imagination?
I mean, it's so easy for us to like see this other thing that does 90% and think, this thing's replacing it because it's newer. I mean, in a sense, right? If you want to make your entire application, use gRPC instead of sending these other messages this other way, you can. There's nothing stopping you. But that's kind of why I said like what are the benefits of each, right? So with gRPC, you get a schema and you can send you can give that to everyone else and they can generate their own code based off of it. But JSON is so easy, right? Like computers are so fast as far as sending data back and forth. Unless you really need it with a public-facing API, I really wouldn't suggest it. But there are ones that do exist, right? When I said earlier that I had my own application and I was debating, well, what am I going to use, gRPC or SignalR or something else? I essentially ended up using kind of both. So I am using SignalR from the service to connect to the clients, however many clients are connected there. But internally within the applications, currently I'm sending protocol buffer messages around. I do want to change that to be gRPC because that's just, I already had it on the Protobuf side. But if I wanted to kind of share this with other people to be able to use, I would immediately, first thing I would do would be to change that to something on the REST side. But again, it all depends on everything. Performance matters. I really like on the SignalR side of being able to just only push changes, right? Like I have to have my code to handle that, but that is so nice to say, hey, everything here changed. How you architect your application then changes. There are some things that are a little bit easier or harder at that point, but it's always the fun trade-offs. Always. Yay. Yeah.
Excellent. Thanks for answering that. And I don't see any other questions. So I think what we'll do is we'll call it a night. But I just wanted to quickly mention that this is one. Oh, wait, Dave has one question.
Oh, yeah.
Two questions. Oh.
All right. I've got the time. It's all right.
I guess he is typing. So, yeah, I also think that with REST, I mean, there's the whole thing about familiarity. Plus, you know, you have Open API and stuff like that that makes it machine readable. So that way, if you want to have machine-to-machine communication, you can use REST instead of gRPC. So, and people have done that. So, okay, so Dave's question is, do you see any reason gRPC could not be used with mobile apps for app to backend communication? That's the first question.
So, I mean, my immediate thinking is no. Like, I don't see any glaring issues with that. You know, just as far as keeping a couple of other things in mind, you know, one of the things with gRPC is, if I'm remembering correctly, by default, it uses HTTPS for how it's sending data back and forth, right? You have to use HTTPS with it, which I think is great. I think everything by default should be with that anyway. If for some odd reason that's a feature that you can't use, I don't know why, but for some reason, then it's, you know, that's something that's going to affect how you choose that. I guess the other thing too, I know there are some issues with HTTP2 as far as the way certain applications, like server side, trying to give you an example, like not antivirus, like firewalls, things like that. I know on the firewall side, some of those apparently don't like HTTP2. I don't know why. I've just read that in a few places. So, you know, if this is something like, you know, on-prem that you control and you're using something like that, it's possible that that could actually mess with that. But other than that, no. I mean, everything with gRPC, it's over HTTP too. But just like with JSON, right? And JSON applications, you can send those over HTTP too. Probably should be sending all of that data over a secure connection with certificates and all that stuff. So no, I mean, I don't see any immediate issue. At least I haven't come across anything. I'm definitely not an expert on this. You know, this, like I said, this whole talk is my, you know, everything that I learned from, you know, all that research, debating which one I want to use. So definitely, you know, I'm sure there's a ton of other resources on that, but no, I can't imagine anything, you know, glaring that I've seen.
Sure. And continuation of the first question, is there maybe a killer app sort of use case for when you might want to choose gRPC over JSON, assuming you want to keep JSON where possible?
Okay. I'm sure there are. Oh, I'm sure there are a lot of things out there, but you know, I really want to point out the performance part of this right here, right? Like, how much data are you sending, you know, over the wire? Are you streaming a lot of data? You know, when we stream, you know, movies, right? That's all sent in a binary encoding because that's less data. I'm not saying that you're going to stream movies with gRPC. That's not what it's built for. But you know. If you have to send data over and over, like really fast, then, you know, I would definitely go with gRPC. And that's why, you know, I gave the video game example right there. If it's like a chat application, that's not going to matter, right? But if you know you are constantly sending data, then that's definitely one of those times where the performance matters a lot, and you need to be able to send that out to everything. Or sorry. You need to query that data right from the client to the server. So that also completely depends on, you know, what your client is doing. Is it able to cache that data? Does it need to get that data 10 times a second? You know, that kind of stuff. So.
Okay. So question 2: is there a way to generate to the Protobuf schema automatically from your C# class layout?
Oh, doing the reverse there. I don't know. There may actually be a tool that already exists Everything that I worked with, I just started on the Protobuf side. Oh, you know what? I'm lying. Of course, yes, there is actually. So let me pull up my browser over here, and we will look up Protobuf.net. All right. So this isn't exactly the same on the gRPC side, but like I said, remember when I said that gRPC is built on top of protocol buffers, and all the messaging we have there. So you can get all of the entities to exist, not the services. That one you are going to have to do yourself. But Protobuf-Net is a open source. It's a library created by Mark Gravel, who works at Stack Overflow, and so they use Protobuf for a lot of the site. And so this is something that I use within my application. I ended up finding this, and so Protobuf-Net is the library that they use in order to work with protocol buffers in a C# style. And what I mean by that is, and I'm hoping for an example. Hey, here we go. Perfect. Code examples. So you do have to start adding your attributes to those entities. So it's not exactly the same as generating a Protobuf file, as far as how you asked. But if you just want this in your code, that is an option. I did read, I think a while ago, that is something that he wants to do, but that was about a year ago, and I never looked into it if he actually did that. And what I mean by that is apparently he has, and you can get this cool global tool to generate that file from your stuff. So yes, there is a way to do that. So the Protobuf-Net stuff. Yeah.
Cool. And a bonus question: have you used, or do you know of anyone using SignalR as a channel for invalidating distributing caching systems like Redis, which are spread out on multiple nodes?
I don't know of anyone doing that. That would be an interesting scenario. Hadn't thought about that, but that would actually be great for that perspective. Because you probably just have a separate service that'll receive the events and do that. I like the concept.
Yeah, cache invalidation is the toughest problem in computer science, so maybe Dave just solved it.
Yeah, there we go.
Yeah.
All right.
Awesome. So, so thanks for the questions, and Al, thanks for coming on here and doing our first ever virtual meetup presentation. So we'll look to do more of these. Obviously, we all are stuck at home, so we'll be doing more of these meetups, virtual meetups. So just join us on our meetup page, meetup.com/ONETUG, and look for more of these virtual meetups. But we also do coffee sessions, and we do lunch meetings, and one of these days we may do a happy hour. So it's a new world, so we are trying to adapt to it. So join us. And Dave says, thanks Al, very informative, appreciate you putting it together, and I echo his sentiments. So thank you very much. And VB2AEs, I think that's Ken. Ken says great presentation. So and I echo his sentiment. So with that, I think we will call this a meeting, and thank you for coming. Take care, everyone. Stay
Thanks for
safe.
having me.
Yep.